As you've probably noticed by now, you need to be able to create ERDs as part of database design. And this process often causes students problems until they've worked through it a few times. So in this presentation, what I'm going to do is step you through how I approach creating an ERD. Now we always start with a problem, and this is the sort of typical problem that we'll find when we have to create an ERD. So the first thing I like to do here is to read through the problem scenario so that I get a bit of a feel for it. And so we see that Central West Airways is a regional airway headquartered in Bathurst, flies to regional and capital city destinations in central and eastern Australia. A fleet of 5 different types of aircraft that range in size from 10-seat planes to 90-seat aircraft, and aircraft that are either 50 or 90-seat capacity have both business and economy class seats. So flights are scheduled to most destinations on a daily basis, but each flight can consist of either 0 or many legs to intermediate stops before reaching their destination. Now, Central West Airways makes all reservations on their website, does not use booking agents. Each passenger must make a reservation for a flight to a destination, and a passenger must hold a valid ticket for a flight to their destination on the specified date. So passengers must select their date of flight, their flight number, the class of travel, whether it's business or economy, and request a seat allocation at the time they make their reservation. And when they've completed their reservation, an itinerary of their flight will get emailed to them. So normally there are some notes and business rules that may come with a problem that we also need to be aware of, and often you'll find these notes affect the scope of the problem, and that's important to us as designers. We need to know both what is in the scope as well as what is out of it. And so here we see that any third-party payment site is out of scope and can be ignored, that the ERD must show names for entities and relationships. The ERD must indicate the cardinality, that is one-to-one, one-to-many, many-to-many, for each relationship, and it does not need to show any attributes because it's an ERD. And so you need then to list any assumptions that you make. And finally, then you get the requirement. This is the problem statement. And this says what you need to do. And here we need to create an ERD. And remember that an ERD doesn't contain attributes, just entities and relationships. So that affects our scope, the scope of our problem as well. It means we don't have to consider ourselves to do that. So the very first step is to look at what are the entities in the problem. And to do that, we have to first identify the business rules. And these are often part of the description of the problem, but the rules tell you how the business operates, what are the major entities, their relationships between them, and they do this as part of the narrative that you read about the problem. So in order to find these entities, we start to look for nouns in the business rules, and these nouns normally define the entities that you need. And some points you should remember here. An entity is something that you want to collect data about. An attribute is some data that you want to collect about a particular entity, and the relationship describes how two entities are linked together. So here's our problem, and what I've done here is I've gone through and I've highlighted all the entities that I could see. Notice that stops, though, as an entity could possibly be exactly the same as destinations. So we could possibly use destinations as the entity and drop stops out, and that's a decision that you as the designer have to make. So the next thing we do after we've identified all these entities is make a list. Destination, aircraft, flight, leg, reservation, passenger, ticket, itinerary. So they're the entities that we've identified. So now we can start to draw our ERD, and we do this by drawing a rectangle for each entity and putting a name in it. And the order we put it on the screen at this stage doesn't really matter just yet, because we're still going to work out what the relationships are. So the second step is we start to determine and identify relationships. And a relationship is normally identified as the verb that links our two entities together. So we also need to look at the cardinality of each end of this relationship, and as well as decide, is the relationship optional or mandatory? And so armed with our list of entities, we can now start to identify the relationships. And so here I've gone through and I've tried to identify some of the relationships, and I've also highlighted some information about optionality for flights, because a flight may consist of 0 or many legs. And so I find the best way to try and sort all this out is to make a table where I can list the entities and the relationships to make sure I've got everything covered. And so here's my table. And so you see, let's have a look at this. We start off by reading this table initially from left to right. So on the first row we see we've got the entity destination with a relationship called of with the entity flight. And we'd read that as destination of flight. And that seems to make sense. But we also remember that we have to read it the other way as well, because we have to be able to read it from right to left. So now we'd read it as flight to destination. And that seems to work quite well as well. Now I see this relationship as one to many. Each destination can have many flights, but read it the other way, each flight can only have one destination. So I see the destination of a flight as mandatory, that a flight is going to go to a particular place, but a flight to a destination is optional, because not all flights are going to go to all destinations. Now the next relationship is between flight and aircraft. Each flight uses an aircraft, which is one of many, but each aircraft can make many flights. So the relationship is actually a many-to-many relationship here. Itinerary and leg also have a many-to-many relationship here, because each itinerary can have one or many legs, and each leg can be in one or many itineraries. So let's start putting our relationships in place on our diagram and see what we have now. So when we start off, we'll go through these entities and relationships slowly so you see how they fit together. So here we'll start with passengers and reservations, because that's where the process really starts. So I see there being a one-to-many relationship between passengers and reservations, and I see it as mandatory. Why? Well, if a passenger doesn't have a reservation, then they're not a passenger. Reservations has a relationship with itinerary, which has relationships with ticket and legs. And legs also has a relationship with flights, which has relationships with destination and aircraft. So I've put my ERD together in a fairly logical manner that starts from the start of the process. That makes sense to me, but you might see it happening in a slightly different way. That doesn't matter, provided that you capture all those entities and the relationships and you show them. Our next step then is to review the ERD. And the first thing here is to resolve any many-to-many relationships with a bridging table. And we also now want to go through the ERD and ask, does it describe the business rules? And then when we finish going through it, we need to ask ourselves again, are you really sure that it accurately describes the business rules? So let's have a look at this. We had two many-to-many relationships, one between flight and aircraft and one between legs and itinerary. So what we've done is we've put in a bridging table or an associative table between aircraft and flight, called aircraft underscore flight, and notice that that bridging table is on the many side of two one-to-many relationships. That's how it works. When you put in a bridging table or an associative table, it is always on the many side of two one-to-many relationships. The same thing applies with itinerary underscore leg, the bridging table between itinerary and legs. Here we show it again as on the many side of two one-to-many relationships. And there we have it. So we've now resolved our ERD, so it no longer has any many-to-many relationships, so it can be implemented. And our final step now is to review the ERD yet again to make sure that it does in fact meet the business rules. And that's the process. It's a fairly simple process, but you need to run through it a few times so that you understand how it works.